Welcome to this lunchtime panel today. A fresh look at toxicity, separating fact from fear. So before I get into introducing this brilliant panel I've got today, I'd just like to set a little context, but also got a full audience here. It'd be really helpful for us if we could see where you're from. So could I maybe have a show of hands from brands and retailers? Yeah, quite a lot of you. Suppliers? Innovators? Couple. And journalists? Not so many. Okay then. And with the topic being around toxicity, anybody here in the audience today that has some slight uncertainty around the topic, or maybe even beyond that to actual fear around the term when we talk about toxicity? Or is everybody quite comfortable with it? Any uncertainty? A little bit? Okay, great place to start. Great place to start. So when we hear the word toxic, we naturally think of harm. By definition, toxicity is simply the degree to which a substance can cause harm to a living organism. So it automatically puts that sense of fear into us. And I think today on the panel, we're really trying to demystify that and make it really accessible and approachable for all of us as we go around the show, we ask questions to the innovators here. So it's not just about the substance, it's about the dose, it's the exposure, and also the context in which it's used in. Take water and oxygen, two simple examples. Neither one of them are either inherently good or bad, but it very much depends on how they're used, and they can actually cause harm through use. So now that we kind of understand about where toxicity comes from and the fear associated with it, we are working in an era where we're seeing phenomenal innovation happening. I mean, this show is just a great example where we've got innovators right across the spectrum in textiles, from raw materials to chemistry to processing innovation. At the same time, we're also seeing a heightened scrutiny around our materials that we're using, what goes into them, the transparency around them. So you can start to see how the picture here is building. We also have some misconceptions, things like bio must be good or synthetics must be bad, and we'll be talking about this a lot more as we go through today's panel. So rather than framing today's conversation around this is good or this is bad, we really want to set the context for people to ask the right questions and feel comfortable about the questions they want to ask. And really understand more clearly this topic, which for some is a little bit scary and kind of pushed away, and it's not my area because I don't understand so much about it. So before I introduce the panel, I'm going to introduce myself. I'm Sophie Mather. I'm an independent innovation advisor and material futurist. I've been working in this space for about 30 years, right across the supply chain. I started in brand with people like Nike, Marks and Spencer's, Lululemon, and then more recently I've been working independently right across the supply chain with non-profits, suppliers, and also as a business founder myself. Personally, I find inspiration in the really hard parts, the bits that other people don't really want to touch. And as a result of that, I have built the business case for a couple of key topics, one being biosynthetics, which I took to the industry in 2010, and more recently microfibers from 2016. So with that, I'm going to introduce this brilliant team that I have with me today. And I'm going to start with Libby Sommer. So Libby is an entrepreneur, an independent advisor working in green chemistry and environmental impact. Her clients include manufacturers, brands, NGOs, all who share a common need for turning data and information into action to drive innovation and systems change. So Libby previously also worked at Nike, but before that was with US EPA, and has since worked with Lululemon and Bolt Threads. So thank you, Libby, for joining us today. And I'm going to kick you off with a question. When you explain chemistry in textiles to someone who has never thought about it, what's your go-to way of making them feel really comfortable about it?
The metaphor that I'm using these days is one of a Christmas tree. If you think about a Christmas tree, whether you've decorated one yourself or seen it in a movie or a TV show, there's always things on that Christmas tree. There's lights, there's garland, there's tinsel. We can choose all kinds of things to put on top of that Christmas tree to get the effects that we're looking for. And when I was a kid, one of my favorite things to do was to turn popcorn into a garland and put that on the Christmas tree. Of course, popcorn is both bio-based, natural, as well as biodegradable. I also liked making ornaments from magazines and canning jar rings, so recycling materials. And all of that is very much an analogy to what we do in the textile industry too. Our Christmas tree is our fibers and our materials, and we add things onto those materials to get the different effects that we're looking for. It could be dyes, it could be finishes, we change the hand feel, we change the properties, the qualities of all of our textiles and materials using chemistry. So there's a lot of inspiration, I think, that can come from that idea of how amazing chemistry is in transforming the materials in this industry. But what does come up for a lot of people is also some of the chemicals that have been more hazardous. And we'll talk a little bit more about toxicity and hazard, but you can think of toxicity as being a spectrum. There are chemicals that are very low hazard, and there are chemicals that are very high hazard. And we haven't always done the best job in this industry of identifying what are those high hazard chemicals, and are there safer substitutes out there. The industry has started to put together lists like RSLs of things that we don't want. Those are the chemicals that we don't want to have in our products generally. But there's a whole other world of somewhere between 3,000 and 10,000 chemicals that are used to produce textiles. And we need to know more about them. And the good story that I do want to impart in this panel is that we now have the tools and the data to get at this problem in a way that we've never had before. So that's pretty exciting.
Yeah, because I imagine 3,000 to 10,000 different chemistries without the tools and resources to understand them really does get quite scary.
It's overwhelming.
But I love that analogy of bringing in the Christmas tree and the decorating, because you make it sound really positive, whereas, if you're just thinking about those 10,000 different chemistries, it could actually be quite scary. So thank you, Libby, for kicking us off. If we move over to Matthias here, he's co-founder and CEO of Beyond Surface Technologies, a leader in green chemistry for the textile industry. Since founding the company in 2008, he has helped pioneer bio-based textile finishing solutions, including Midori, now adopted by major brands such as Patagonia, Levi's, Adidas, and Lululemon. With decades of experience spanning global chemical companies and innovation leadership, Matthias continues to drive sustainable chemistry solutions across the industry. Thank you for joining us today, and I'm going to kick you off with a question here as well. So you talk about, having 4 decades or almost 4 decades in textile chemistry, the first half of what you call the dark side of the force, and I love that when we spoke before. So what has that actually taught you that shapes how you work today?
Thank you. So the first 2 decades were on the dark side of force, and then I joined the rebellion. To me, it was fundamental because it helped me to really completely understand how the industry works, especially the supply chain and what the different needs within that supply chain are, and how the textile chemical industry approaches innovation, including toxicity within those different parts of the value chain. And so for me, or for the company that I started 18 years ago, right, there were some key learnings or observations that we try to never forget, right? One, and stating a few obvious, I guess, it's such a conservative industry. So the mills are running 24/7, they know their processes, they know their chemicals, so nobody is waiting for you to come in and change these running processes. And the biggest topic for us was, okay, we need to dare to be different, but scalable. The key thing is the scalable part as well. if you cannot offer to the industry something that can be adopted widely across it, or widely within the value chain, it's so difficult to get people change what they currently do, right? And internally for us, that meant we needed to avoid one trap that I saw chemical corporations, and being part of it myself, falling into time and time again, is that becoming excellent in incremental innovations. So trying to give some examples, if you look at, let's say, the denim industry, right? You can look at 15 different single processes. And from a corporate perspective, there's chemicals used within each process. So you try to innovate within each process and come up with something new to present, right? But I would argue, if you look at the overall thing, you only come up and presented incremental step forwards, and you probably missed a larger step that you should have been working on.
Yeah, looking at the bigger picture, working more collaboratively and really understanding the supply chain. Absolutely. And I love how you bring in that early part of your work, understanding the supply chain to enable you to innovate in an area that is going to be scalable and work for the industry. So thank you. And now we're going to move over to Irene Maffini, who is an investor and operator at the forefront of sustainable fashion. Over the last 16 years, she has backed 40 climate tech companies, 16 of them in sustainable fashion, spanning material innovation and circular services, many of which you'll find here showcased at these two exhibitions this week. She is also an investor and chief commercial officer at Dye Recycle, a spin-out for Imperial College London that removes the chemistry that makes post-consumer waste unrecyclable. So great work. And I'd like to direct this question to you. As someone who backs innovation in this space, when you're looking for an innovator to back, at what point does chemistry actually become a deal breaker for you?
Yeah, thank you. So for me, chemistry becomes a deal breaker when it's a liability that a founder has not priced in, and there's no roadmap to look at the various challenges. And at the beginning, I don't expect companies to have figured it out. But I guess I learned the hard way the impact of chemistry on end of life of products, and as well as then on the toxicology profile of the materials. And to go more into the specifics, having backed many bio-based materials and also now being on the receiving end of the recycling, at Dye Recycle, we receive all of the textile waste that no one can recycle. I've learned how hard it is then to recycle clothes just because you have added a little bit of chemistry that shouldn't have been maybe there in first place. So in my journey, I learned the hard way that a lot of the materials that maybe I backed or I've seen on the market. I think there's some issues.
Oh dear.
It looked like there was some big noise from the reaction of people.
Yeah, you can hear now.
Yeah, it's back.
Thank you.
I will kind of restart saying that what I've seen in the market and in my experience that a lot of companies start with very high ambitions. They want to create a 100% bio-based material, monomaterial, that can be home composted in our homes and no finishing chemicals. Then the commercial reality hits, and they need to create a product that meets certain performance targets from brands, and also that sometimes might be also too high, you could argue, but also specifically you need to hit certain price points. So all of these vision gets diluted. Then is a percentage of bio-based material. Then you start adding a polyester backing. Then you start adding flame retardants, and each decision in isolation makes sense. But when you put it all together, you had this idea of this new, amazing new material, and you created a little monster that cannot be recycled, or that it will be very hard to recycle with current technologies. So for me, what I look at, is no perfection, but knowing, honest conversation about these are the key gaps, And this is the roadmap I am, I'm looking to go into to try to find the best formulation that has a good effect on the end of life using existing technologies. And this is very much, what also AI now can support in accelerating this kind of material and formulation discovery. And then the second point that's very important, and I think still a big unknown in this industry, I think, is the toxicology profile. And being very specific here, looking at PFAS, we all know how, the evolution from, long chain C8 chemistry to short chain C6 chemistry has created regrettable substitutions. And I'm very concerned that also a lot of the C0 chemistries, with few exceptions, is creating a lot of other regrettable substitutions where we actually have no idea about the toxicology profile and other things. So for me, these are kind of the two areas that can become deal breakers. And there's no perfection, but there needs to be a roadmap to look into the details of these.
I love that. Roadmap, looking at the end first to kind of work backwards and look at what's needed. And very similar to what Matthias was saying about, understanding the supply base. This isn't something that we work in isolation, but very much connected right across. So last but very much not least there, Sumitra Rajagopalan. Sorry, I've got that wrong. An inventor and entrepreneur with degree in biomedical engineering, material science and chemistry. She is founder and CEO of Bioastra and founder of Tira Fibers. For her, chemical safety is at the forefront of all Bioastra's innovation, and she's working with major fashion brands not only to bring sustainable materials to market, but raise the awareness of worker exposure to intermediate chemicals. And I think that's a really important point in today's conversation. But also last year, she founded the Cooling Pact to address heat stress also during manufacturing. So thank you for joining us as well, Sumitra. You've built something genuinely exciting in the biospace, and you talk openly and about transparency and going beyond sustainability as the narrative. So what does this actually mean when it's your own product and it's your own business that you're actually scrutinizing?
It makes it all the more easier because you know exactly what's going in and what's not supposed to be there, even though it is. So thank you, by the way, for inviting me on the panel. Great to be with all of you and all of you in the audience. Transparency has been framed as something virtuous, something morally right principle. It's just good business. Why wouldn't you divulge things early on? We're all in this together, and we're learning. And if we look at, we call it the dark forces, well, maybe, but materials weren't designed to be good or evil. They were designed for function. And at the time when all these iconic materials came into being, we didn't have the same awareness of end of life as we do today. If you remember the old adverts with nylon, they actually advertised the fact that it would last forever, nothing would degrade it, and it was the sales pitch, if you remember from very, very long ago. I think it was a black and white commercial. So let's contextualize. So you talked about chemistry for Libby. Let's contextualize chemistry for the time, a bit like history. History is understood and appreciated in the context, in the time it was. So should any science. So today we are fortunately aware of not just performance, but what happens at the end of life. I would like to think that at Bioastra we've gone beyond the 100% bio-based claim to look at some of the intermediate chemicals that don't make its way to the final product, but it affects workers, and which should be just as important as what is actually worn next to the consumer's skin for the, high-paying, fancy garment. So I think we're just one of many, hopefully doing the right thing. It's good business, and to be very honest, Irene spoke about databases and AI, but even outside that, the sheer volume of information we have out there in terms of substitutions and what could be used in its place, I think should be an opportunity for all of us. And the other point I think I just wanted to touch on in terms of replacing something, I know no good or nor bad, but say replacing an incumbent with something green and then having the law of unintended consequences that you alluded to. So I'm fortunate to be both, chemist, material scientist, and biomedical engineer, and I just see that chemistry is being taught today the way it was taught in my great-grandfather's time, the same textbooks, and I would love to see more of the engineering rigor in building new molecules. So could we start looking at new molecules not as chemists, but as architects, as engineers? And when we do that, we get past the this is good, this is bad, this is toxic, and we have a whole systems approach. So design is actually the heart of engineering rather than number crunching, as people know. And if we were to design molecules from the ground up, we will necessarily take into account everything that you said. And unlike like when you cross a bridge, the civil engineer never had to say, oh my God, I have to either hold this or allow cars to push through. There are conversations we have in chemistry you won't hear in any other engineering field, you know. An airplane flies and it's very heavy. So I think we should get past this contradiction and trade-off mindset. We're either performing or it's bio, it's either safe or it's this, and really build for everything, and it's possible with the engineering mindset.
Design from the bottom up.
Absolutely.
Yeah, very much designed from the bottom up with the end in mind.
Absolutely.
So great. I'm going to switch to Libby, and going back to that 3,000 to 10,000 chemicals that you spoke about. I imagine many of those are from bioresources. Is there a myth or something that you hear often around that you would like to lay to rest in today's conversation? I kind of hinted at it in the opening.
How much time do we have for myths about chemistry?
Halfway.
So another 25 minutes. So many myths. You know, one is that I'm sure many of you have heard the term bio used in some sort of context. This is bio-based or bio whatever. I see it all over the show. And it's always a good one to inquire further about, because it can mean a bunch of different things. It can mean it comes from a biological source like, you know, cotton. It can mean that it is carbon-based biological content that's transformed in a synthetic process into something that is not naturally occurring. You know, we use that term to apply to a lot of things. When the USDA in the US created their bio-preferred program, someone did a survey of institutional purchasers at that time. And they said, how many of you think bio-preferred means safe? And it was a majority of them. And that's not at all what it means, at all. It simply means bio-based, or in this case bio-preferred for USDA, simply means that the carbon content in that product comes from a biological source. It is absolutely possible to make the exact same molecule from a biological source as from a petroleum-based source, and there is no difference in toxicology, absolutely none. So there's no correlation between whether something is bio-based and its safety. To understand the safety or the hazards of a chemical, you really need to delve deeper into the molecular structure of that chemical and the toxicology data that are out there. And that used to be really intensive to do, and now there's some amazing databases out there that are very inexpensive and very easy to access to understand the impacts of different chemicals. So that's one myth, is this idea that bio-based is always safe, and it's really about the structure of the molecule. It's not about whether it's from carbon from a natural source or a petroleum source.
It's about, you know, empowering people to ask the right questions, know what to look for, and know how it's going to fit into their product so they're using it correctly. Yeah, great. Thank you, Libby. Mindful of time, I'm going to switch up a little bit here. Irene, where you sit as an investor, what's the challenge no one's talking about loudly enough when it comes to chemistry and circularity?
I guess everyone, you know, now we all talk about moving from an outdated linear model to, you know, a perfect circular model, but the reality is that we have these, you know, circular like hoops that actually have a lot of like chemical kind of leakages, and I think focusing on those is, I think, an opportunity, and is an area that investors that look, you know, in depth into this space are now looking to address. So, for example, in the context of recycling and textile recycling, as you know, there are many brands in the audience. 99% of what goes into recycled polyester is from bottles. Bottles are going to disappear because they're going to be back to packaging because of incoming regulation. So, and at the moment, there's no way to actually scale textile to textile recycling because of the chemistry actually in the clothes is preventing the recycling. If you speak to any recyclers, with very, very few exceptions, they're all sourcing white or clear post-industrial waste. They are not operating on post-consumer waste. And this is like a huge structural gap. So originally, I actually invested in DieRecycle, which now I'm Chief Commercial Officer, stepped into operationally to lead on the commercialization because this is such a big problem. And at DieRecycle, we started with the most obvious contamination in the waste, which is the one you can see, the color. So removing the color means then you have white fiber that actually can go into recycling. We don't want to be a recycler. We are a pre-processing step for recycling. And this whole pre-processing infrastructure is really critical. I was this morning at the launch of the pre-processing project with Fashion for Good, which is now being recognized, as a huge kind of problem. It's not just about the dyes. Then when you look into it, most of our waste is polycotton. So with DieRecycle, we take the cotton and that becomes nanocrystalline cellulose, which is a platform technology in itself. We used it a little bit as a pigment for kind of dyeing, but there are so many applications. And then when you start looking at other contaminants, it's the elastan. And then there's all of the finishing chemicals. So this for me is, it doesn't like me.
And again.
It's fine. It's my Italian shouting. Yeah. Yes. Thank you so much. Sorry. So. Is the volume back? I don't know.
Is it
Yes.
just Irene that they can't hear?
It's not personal, no.
Maybe it's my microphone.
Is it working? Can you hear me now? Yeah? Irene,
Can you
have
hear
it?
me?
Irene now.
Yes.
Yeah. Okay.
But yeah, I think
Yeah, great.
I finished it.
Yeah,
so I
no,
think-
thank you
yes.
very much. So yeah, I mean, great that we've got the two shows together. So, the mindfulness of the end of the pipe and the recycling that's needed is really important. Matthias, I'm going to switch over to you here and ask you to talk a little bit about the waterless dye that you're launching here at the show. Walk us through your thinking behind this. What were you trying to eliminate, and why does it matter more than finding safer substitutions?
It's the latest project I've been involved in, and it's a six-year project in working, and it just tackles the idea of innovation differently to what I described that the corporate approach might be. So we picked to start with the segment of denim because it's the single biggest textile segment as a single garment. There's this incredible amount of 4 to 6 billion denims produced every year. And then if you look at, there's like 10 to 15 process steps involved. And in each process step, there's chemistry used, right? So the old, or the May corporate approach would have been to look at each single step and try to optimize the chemistry used in each step. We said, okay, if we dare to be different, if we dare to be radical, right? Why do we need all these steps? Because toxicity also relates to dosage, right? If whatever we do has an impact on the planet, even if we use the best bio-based materials, we still do impact the planet. So if I can find something that reduces the amount that's needed to be applied, it mitigates a lot of the toxic risks. Yeah. So, exactly, that's everything we have heard before coming together here. So with waterless, what we have done is, if you look at denim, we basically collapsed a 15-step process into a single process step. And all the auxiliaries that you have used for those other processes are being eliminated. So as a rule of thumb, right, there's like the ratio between the dye and the auxiliaries is 1 to 4. So there's 4 times more auxiliaries used within a process than dye. So all of those auxiliaries we were able to eliminate or eliminate the petroleum. So how we now suggest denim can be produced with no compromise on look and feel is using digital technology. So we came or invested time into software, inks, and a bio-based ink activator, let me say, so that you can take your ready-to-dye fabric, you run it through a printing machine, you print the face, the fabric turns in the machine, you print the back, you have your dunning look, you come out, and it's done. No post-washing, no steaming, and how, from a vision perspective, we can see how my CEO job as Beyond Surface Technologies and the waterless technology can merge together. We are currently working on making all our bio-based finishes applicable through digital printing heads. And if we succeed with that, then you can easily imagine just combining the two technologies and you have a fully dyed and finished fabric in one single process step. So tackling toxicity from a very, very kind of different angle by reducing the amount of substances you need to treat a fabric.
I love that. I know when we were speaking before, when you said, let's just eliminate it, music to my ears. And I think, Libby's going to talk about a tool in a minute as well, and also talking about the transparency, Sumitra, that you were talking about earlier on. You eliminate it, you understand it, you've got a way to kind of map it and have that full transparency. That's ultimately, what we're heading towards.
Maybe I should add one more thing, because that's the toxicity angle, right? But just like from an overall perspective, that technology allows you to do that with 2 tablespoons of water per denim. So, that's the next bit. Water is going to become the scarcest resource we'll have, and textile is using a lot of water. So we were, in one go, you basically tackle toxicity from chemical input and wastewater creation at the same time.
Thank you very much. So I'm going to go over to Sumitra now and come back to bioelastics that you spoke about before. 100% bio-based, but going back to that point you made about transparency, I know when you first started working on it, you spoke to me earlier about how you found things that were actually lurking that you weren't expecting. Can you tell us a little bit about this light bulb moment, kind of that changed your approach to working?
So first, remove the ideology and just think purely in function. That helps, removing all the titles that, labels one associates with chemicals as being good and bad. So I would like to believe we have provided viable alternatives to polyurethane in all its forms. So from a sustainability perspective, when you hear of polyurethane, you would think of isocyanate, and you would hear everything that, everything that's wrong with chemistry in that one molecule of being toxic. It's a health hazard, it has to be controlled. The way it works in chemistry is the very thing that makes it scary or aka toxic is what makes it amazingly performing. And it's a reason why these chemicals endure. So rather than stigmatize or villainize the chemical, understand the function. Now, in our early days, by definition, the bio-based or biodegradable feedstock we used, by definition, underperformed, because it's just a fact that bio-based materials melt, at slightly lower temperatures, and the benign materials are benign almost because they don't react as much as the ones you're trying to replace. But once you understand, again, putting on my engineer hat, once you understand the conundrum, you don't see it as a problem anymore. So we just break through those contradictions. So that is one. So we put ourselves, our entire platform, by the way, welcome to see it, C22, straight there. Citric acid was the building block. So citric acid even just sounds lovely, doesn't it? Benign and also wonderful. And we have waste feedstock, we have sugar-based, and it's even available as petrochemical. But reactivity is a problem. If you tell a polyurethane manufacturer that's used to getting their materials molded in seconds that, hang on, it's going to take minutes and hours, it's a no-go. So we're just performance to performance. We had it in the first 6 months. Where it genuinely drop in, where manufacturers can use it, that was the story of the next 3 years. So 3 months versus 3 years. in hindsight, we would have started from day one working on drop-in production, cost parity, knowing that performance, I mean, ironically, is probably the easiest part of the puzzle. So, sorry, I'm going to re-emphasize the point. When you stop seeing structure and chemistry and you look purely at function, including how it should behave at the end of life, that's when light bulbs start lighting up, at least here and in my team.
Yeah, and I
that's
like
the
that.
result,
It's
yeah.
often the hard places where we get the best innovation coming through. And
Right.
I'm always heard to be saying it's the roadblocks that turn into opportunities. And it sounds like you
That's
very
where the
much went through
innovation
that.
is, yeah.
So yeah, thank you for sharing that. Going to switch back to Libby now, and you've been working on a new tool. So when we think about resources and where people can go for extra information, been working on a new tool called ChemForward that has done assessments. It's come from the NGO ChemForward to pilot a system level evaluation of chemistry in our industry. Can you tell us a little bit about this work and what particularly surprised you with the outcomes that you got from it?
So ChemForward really kind of grew out of the Cradle to Cradle Institute. Stacy Glass, who's one of the co-founders of ChemForward, worked at Cradle to Cradle, and she realized that the number one barrier to accessing that standard was the safety of the chemistry that was used in products that were submitted to for assessment. And not only that, it was also how do we assess those substances? It takes a highly qualified toxicologist who typically has a PhD and has board level certification to do a toxicological assessment of the sort that are reliable for business decision making, for regulation. So those are highly trained people with a lot of expertise, and their time is valuable. It can also take a lot of time to review a toxicology study. Some of them are 500, 800 pages. So it's trying to sort through something like that and decide, well, is this something that I should care about or not? Like ultimately, you kind of need just a yes or no. Effectively, it takes a lot of time. When I was at the EPA, we spent a lot of time with our toxicologists in the chemicals regulatory office doing those sort of assessments. And we kept seeing, this company would submit this product, and then the next company would submit their product, and their ingredients were almost the same, or very little variation between those. And so if you're doing that sort of assessment for every company individually, that's a lot of duplicated effort and waste of effort. And so we started to think about, okay, how do we create like a database where you can find safer ingredients and think about it from a product's perspective. What ChemForward is doing now is thinking not only at a product level, but also at a systems level. And I think that this industry is very, very ripe for that. We've done a lot of RSL testing. We've done a lot of lists of things that we don't want to include in our products. But back to that 3,000 to 10,000 chemicals that are in use to make textile products generally, only 400 or so are on RSLs. I can tell you that there are lots of other chemicals that have the same types of concerns as substances that are on restricted substances lists. But regulation and that sort of approach is very much a lagging indicator. It takes somewhere between 10 to 20 years before there's an issue identified with a chemical, before there's actually regulatory activity to address it. And PFAS is an amazing example of that. I mean, it was 30 years ago where some of the first studies of workers in facilities that produce PFAS were starting to filter into EPA, and I'm sure into the European Chemicals Agencies too. So it took a really long time for activity to happen on that chemical, and that's just just an example of that. So at ChemForward, what we're doing is we're piloting this approach, and ChemForward did this with cosmetics, where they looked at the whole sort of inventory of chemistry that's used to produce textiles and create a profile of what those hazards are, which have information to actually understand their impacts and which don't, because that's also a problem. We don't always have insight into toxicity. of those substances used in textile production that do you have information to understand their impacts? How many are low hazard, so relatively benign? How many are high hazard and more of a concern? And this is the first time that I have ever seen this industry do sort of a systems level look at the impacts of these chemicals.
Sounds like it's going to be hugely valuable.
Yeah, and what I think we're not trying to create a new initiative, we're trying to then take this idea and embed it into other systems. So there's lots of other tools that already exist that are great at pulling information from supply chains, but they don't necessarily capture the impacts of what's being used in production. And so this is sort of a pilot to show, hey, we have a way now to think about this. Let's embed this into tools and systems that already exist so we can get beyond just is it on an RSL? And beyond to, is it actually low hazard, or are there things that we can see kind of coming down the pike that we want to be worried about?
Great. Thank you very much for sharing that. And it sounds like then that people here in the audience will be able to access it through other platforms.
There will be a report coming out this year,
Super.
but I'm here for the full show. Happy to have a conversation with anyone about that.
On that point, we've been asked to move to Q&A, but quickly before we do, can I just ask the panelists for one quick bit of information? Anything at the show that you really want to signpost to people? I know we've got some great hubs, but just really quick fire, and then we'll open up to questions from the audience. Matthias, do you want to go first?
Anything that I haven't been able to see anything
Okay,
yet.
so signpost to your stand. What's your stand number for the
Okay, we are at AX8, obviously, and been busy ever since.
Super. Okay, and Libby, the Chem Forward will be, people will be able to access it through the report later.
Yeah.
Sumitra?
Aside C22 straight up, I would love conversations on going beyond our proprietary stuff to see how we can work together and maybe open source some of the knowledge on intermediate chemicals, solvents, plasticizers, which are common, and see how we can build this database together and uplift the industry as a whole.
Super. Nairi?
Since we discussed a lot the PFAS topic, I would like to there is a new part of the exhibition on the back on the right that talks about PFAS and some of the kind of free, safe alternatives like beyond surface technologies. And also, if you are interested in textile-to-textile recycling, decontamination of waste, Recycle though is in the recycling conference on the other side.
Super, and I want to just add a couple as well. So lots of really good hubs here. You've already spoken about one. Material transitions focused on biosynthetics, so we touched on bio today a lot. And also one on biodegradation, which is also going to be useful for people as well. So please take the information from the panel and take it off to the show and use it for questions. But I'm going to go to a couple of questions from the floor. So what is the biggest comprehension hurdle in this subject, as there is so much good work going on, but people do not actually know the actual problem? What is the comprehension hurdle?
Subject.
For the
What subject?
toxicology, and I'm looking at Charles for a nod.
Okay.
Thank you, Charles. Yeah.
It's very complicated.
Yeah.
And I think you need to start on kind of some areas that I guess are now more on the media. So I think, PFAS is a good example.
Yeah.
We have had a few articles on The Guardian and they specifically focus on the PFAS in kids' uniforms. And then we had a good article on the Financial Times on how toxic is your sportswear. So I feel like, you need to educate yourself on so many different chemicals of concern, like Libby was saying, and focusing on the ones that people start talking about.
Yeah, definitely. And I think also, going back to the hubs that we have here, there's brilliant resources on them where it's got key questions to ask. So if you're talking to a supplier, so I think that also helps build the comprehension in the areas that are important. So thank you for that question.
Sophie, if I can just add, because I think we do ourselves a disservice in chemistry to making it complicated, and this is something that science struggles with a lot. But I would say if you are trying to understand the impacts of something, ask whoever you're talking to, can you provide me with a chemical hazard assessment? Those are the words to use, a chemical hazard assessment. And we have some resources on Chem Forward that talk more about that. But that's a really important tool. Life cycle assessment is not the tool to use to understand toxicity. It will not help you with that.
People here, just in their day jobs, can they understand a chemical assessment
Yeah,
it won't be
there's-
written in.
It's a visual kind of thing, so you
Perfect.
can sort of see red, yellow, green. Like, what are the issues here?
So they don't want to be afraid of asking for it and then not being able to decode it or
Right.
understand it.
Yeah,
Okay, brilliant.
yeah.
Great information. What role do the panelists see for policy in terms of supporting much greater disclosure of substances used in production processes across the supply chain? So policy, I suppose.
Well, I'll just offer that, right now, when you look at anyone raise your hand if you think Europe is the most active on chemicals legislation in 2025. Like, I would raise my hand, right? That was wrong. It was the US. Does that surprise you? It surprised me. And that's because US states are super active on chemicals legislation, especially PFAS, but also other substances too. So New Mexico, Minnesota, California, all of these states are proposing different regulations and putting them into force. There's a real challenge with lack of harmonization across those regulations. There's a big, I think we're encountering in Europe, and this will happen in California as well, challenges with how do we deal with the need, the interest, the value of recycling textiles, but yet all these legacy hazardous chemicals that are in post-consumer textiles that actually violate current regulations on hazardous substances. And I see nods in the audience, and I'm sure some of you have encountered, even in years past, where you try to use a recycled textile and the supplier can't guarantee that it meets regulatory requirements because they're pulling in hazardous substances that were used, decades ago on those textiles. We really have to figure out how to rationalize those two goals, because we have a real struggle right now in the industry to try to eliminate some of the hazardous substances and try to avoid that future PFAS, but also make textiles recyclable going forward. And so I think regulation needs to help us figure out how do we balance that and how do we incentivize the adoption of safer chemistry where that exists. There are lots of safer alternatives out there, and this industry did an amazing job of substituting things like nonphenol ethoxylates for safer alternatives, but we need to keep doing that.
Yeah. I think that sounds like a panel all of itself.
Yeah.
It's really
True.
complex, and also how we can actually influence the legislators as to the legislation that's coming through in the future.
Yeah.
So I think we are running to time, but I'll take just one more question here. Let me just see. What are the opportunities and threats of the EU bioeconomy strategy for promoting good bio-based fibres, i.e. Organic fibres and processing? So what are the opportunities and threats of the EU bioeconomy strategy for promoting good bio-based fibres?
I may not be aware of all the details, but I do have some familiarity. I have noticed that the definition of bio gets a little narrower with time, and that is problematic because we have a hard time anyway keeping up. It is. I knew that that actually California is the most restrictive, where common biopolymers are actually not considered bio-based or sustainable. So I think the opportunities, obviously, for innovators to out-innovate these bans, but the other one is for legislators to be just mindful about the pace of innovation, and it's a lot faster to write laws than it is to come up with substitutes. So I guess, I don't know, did you ask if there were any policymakers in the audience? Show of hands. I think we have to all agree and involve industry in agreeing on definitions of what they are, because even though I'm in the field, sometimes I do have to do a double take to know what a particular term means and where bio-based ends and where the other thing begins and so on.
I think that's a
so
really good kind of call to
let's just agree
action.
on what the real problem is and maybe not keep narrowing it over time, as that seems to be the case.
Great. Well, with that, I'm going to conclude today's conversation and thank my panelists, Matthias, Libby, Sumitra, and Irene. So thank you for your questions and your attention today.